Welcome to the Holographic Universe. This is part 1 of a 5-part workshop series designed to examine how quantum physics and recent scientific experiments are radically changing our understanding of life, our reality, and our spirituality. For example, in January of 2012, scientists at the GEO 600 gravitational wave detector in Germany announced they now had scientific evidence that the entire universe is a holographic projection around the Earth. We'll take a look at that claim in detail later in this workshop. But first, imagine, if you can, living 500 years ago when many people thought the Earth was flat, and we based our opinions, beliefs, judgments, and fears on that one elementary but very mistaken premise, like falling off the edge of the world if you sailed too far west from Portugal, and how that limited human lives and experiences. When we found out the Earth was round, we had to make some serious adjustments in our thinking. But unfortunately, you're going to discover in this workshop series that we simply traded one set of limiting beliefs for another. Well, we're at a turning point in history once again, and I want to share with you this revolutionary idea that we are living in a holographic universe, and explore what that will mean in our everyday lives. Which brings up the question, who am I? And what are my qualifications to present this workshop? My name is Stephen Davis, and that's really all you need to know, because I am not the one who will be speaking to you today. Although you will be hearing my voice, you will not be listening to my beliefs, or my opinions, or my theories, because I am not an expert in quantum physics. I'm simply the messenger. My job is to bring you the message that the Earth is round, and show you the scientific evidence for it. And I'm qualified to do that mainly because I have sailed around the world and experienced it for myself. But to present the scientific evidence is a different matter, and to do that I have brought with me the real experts to talk to you about quantum physics, through video clips and audio files and quotes from their books. I want you to hear all of this directly from them. And then, if you disagree with something you hear, you'll have to argue with the experts, and not with me. For example, in 1991, Michael Talbot wrote a book called The Holographic Universe. Unfortunately, Michael died in 1992, just a year later. So this book is already 20 years out of date, and there's been a lot that's happened during that time in this field. But still, it's one of the best books I know to get started, and you'll be hearing a lot of quotes from it during these workshops. You'll also be hearing quotes from The Field by Lynn McTaggart, another excellent basic introduction to the subject. And you'll be meeting and hearing from a lot of different experts, mainly physics professors at various colleges and universities from all over the world, such as David Bohm, renowned quantum physicist at Princeton University; Carl Pribram, neurophysiologist, Georgetown University; David Albert, Director of Philosophical Foundations of Physics, Columbia University; Richard Feynman, Professor of Theoretical Physics, California Institute of Technology; John Hagelin, Physics Professor at Maharishi University; Stuart Hameroff, Associate Director of the Center for Consciousness, University of Arizona; Nick Herbert, Assistant Professor of Physics, Monmouth College; Michael Ledwith, Professor of Systematic Theology, Maynooth College in Ireland; Andrew Newberg, Director of the Center for Spirituality and the Neurosciences, University of Pennsylvania; Dean Radin, Professor, Saybrook Graduate School; Jeffrey Satinover, Teaching Fellow in Physics, Yale University. Leonard Susskind, Professor of Theoretical Physics, Stanford University. William Tiller, Professor Emeritus, Stanford University. Fred Alan Wolf, author of Taking the Quantum Leap and Parallel Universes. Brian Greene, Professor of Theoretical Physics, Columbia University. And many, many more. But I want to introduce you first to Dr. Amit Goswami. Dr. Goswami is Professor Emeritus in Theoretical Physics at the University of Oregon, Senior Scholar in Residence at the Institute of Noetic Sciences, and author of 9 books on quantum physics, including The Self-Aware Universe and Science and Spirituality, A Quantum Integration. Listen carefully to what Dr. Goswami has to say.
This is the only radical thinking that you need to do. But it is so radical, it's so difficult, because our tendency is that the world is already out there, independent of my experience. It is not. Quantum physics has been so clear about it.
This is the only radical thinking that you need to do. But it is so radical, it's so difficult, because our tendency is that the world is already out there, independent of my experience. It is not. Quantum physics has been so clear about it. You'll be hearing that quote probably half a dozen times over the course of these workshops, and each time you hear it, it will make more and more sense. But now let's begin by taking a trip into outer space and then back into inner space with a video called The Powers of 10. Pay particular attention to what outer space and inner space look like.
The picnic near the lakeside in Chicago was the start of a lazy afternoon, early one October. We begin with a scene 1 meter wide, which we view from just 1 meter away. Now every 10 seconds we will look from 10 times farther away, and our field of view will be 10 times wider. This square is 10 meters wide, and in 10 seconds the next square will be 10 times as wide. Our picture will center on the picnickers, even after they've been lost to sight. 100 meters wide. The distance a man can run in 10 seconds. Cars crowd the highway. Powerboats lie at their docks. The colorful bleachers are Soldiers Field. This square is 1 kilometer wide, 1,000 meters. The distance a racing car can travel in 10 seconds. We see the great city on the lake shore. 10 to the 4th meters, 10 kilometers. The distance a supersonic airplane can travel in 10 seconds. We see first the rounded end of Lake Michigan, then the whole Great Lake. 10 to the 5th meters, the distance an orbiting satellite covers in 10 seconds. Long parades of clouds, the day's weather in the Middle West. 10 to the 6th, a 1 with 6 zeros, 1 million meters. Soon the Earth will show as a solid sphere. We are able to see the whole Earth now, just over a minute along the journey. The Earth diminishes into the distance, but those background stars are so much farther away that they do not yet appear to move. A line extends at the true speed of light. In 1 second, it half crosses the tilted orbit of the moon. Now we mark a small part of the path in which the Earth moves about the Sun. Now the orbital paths of the neighbor planets, Venus and Mars, then Mercury. Entering our field of view is the glowing center of our solar system, the Sun, followed by the massive outer planets, swinging wide in their big orbits. That odd orbit belongs to Pluto. A fringe of a myriad comets too faint to see completes the solar system. Ten to the 14th. As the solar system shrinks to one bright point in the distance, our sun is plainly now only one among the stars. Looking back from here, we note 4 southern constellations, still much as they appear from the far side of the Earth. This square is 10 to the 16th meters, 1 light year, not yet out to the next star. Our last 10-second step took us 10 light years further. The next will be 100. Our perspective changes so much in each step now that even the background stars will appear to converge. At last we pass the bright star Arcturus and some stars of the Dipper. Normal but quite unfamiliar stars and clouds of gas surround us as we traverse the Milky Way galaxy. Giant steps carry us into the outskirts of the galaxy. And as we pull away, we begin to see the great flat spiral facing us. The time and path we chose to leave Chicago has brought us out of the galaxy along a course nearly perpendicular to its disk. The 2 little satellite galaxies of our own are the clouds of Magellan, 10 to the 22nd power, 1,000,000 light years. Groups of galaxies bring a new level of structure to the scene. Glowing points are no longer single stars, but whole galaxies of stars seen as one. We pass the big Virgo cluster of galaxies among many others, 100 million light years out. As we approach the limit of our vision, we pause to start back home. This lonely scene, the galaxies like dust, is what most of space looks like. This emptiness is normal. The richness of our own neighborhood is the exception. The trip back to the picnic on the lakefront will be a sped-up version, reducing the distance to the Earth's surface by 1 power of 10 every 2 seconds. In each 2 seconds, we will appear to cover 90% of the remaining distance back to Earth. Notice the alternation between great activity and relative inactivity, a rhythm that will continue all the way into our next goal, a proton in the nucleus of a carbon atom beneath the skin on the hand of the sleeping man at the picnic. Ten to the 9th meters, 10 to the 8th, 7, 6, 5, 4, 3, 2, 1. We are back at our starting point. We slow up at 1 meter, 10 to the 0 power. Now we reduce the distance to our final destination by 90% every 10 seconds, each step much smaller than the one before. At 10 to the minus 2, 1/100th of a meter, 1 centimeter, we approach the surface of the hand. In a few seconds, we'll be entering the skin, crossing layer after layer from the outermost dead cells into a tiny blood vessel within. Skin layers vanish in turn. An outer layer of cells, felty collagen. The capillary containing red blood cells and a roughly lymphocyte. We enter the white cell. Among its vital organelles, the porous wall of the cell nucleus appears. The nucleus within holds the heredity of the man in the coiled coils of DNA. As we close in, we come to the double helix itself, a molecule like a long twisted ladder whose rungs of paired bases spell out twice, in an alphabet of 4 letters, the words of the powerful genetic message. At the atomic scale, the interplay of form and motion becomes more visible. We focus on one commonplace group of 3 hydrogen atoms bonded by electrical forces to a carbon atom. 4 electrons make up the outer shell of the carbon itself. They appear in quantum motion as a swarm of shimmering points. At 10 to the minus 10 meters, 1 angstrom, we find ourselves right among those outer electrons. Now we come upon the 2 inner electrons held in a tighter swarm. As we draw toward the atom's attracting center, we enter upon a vast inner space. At last, the carbon nucleus, so massive and so small. This carbon nucleus is made up of 6 protons and 6 neutrons. We are in the domain of universal modules. There are protons and neutrons in every nucleus, electrons in every atom, atoms bonded into every molecule out to the farthest galaxy. As a single proton fills our scene, we reach the edge of present understanding.
You can see that outer space and inner space look very much alike. Lots of empty space. This video was made in 1977. As technology improved, scientists kept going deeper and deeper, and they found smaller and smaller particles and more empty space.